Welcome. Yeah, so problem 14 and a peculiar but very interesting integral. Now, to start, notice that sine of x plus 1 is equal to 2 sine of x over 2 cosine of x over 2 plus 1. And that's because sine 2 theta is equal to 2 sine theta cosine theta. So if we let theta equal x over 2, then x is 2 theta. So this is sine 2 theta, and therefore it is 2 sine theta cosine theta, and obviously the plus 1 there we must keep, right? Now, notice that a plus b all squared is a squared plus 2ab plus b squared. And so we kind of have a 2ab here. We just need an a squared and a b squared. Well, since a would be sine of x over 2 and b would be cosine of x over 2, we see that a squared plus b squared, which is sine squared x over 2 plus cosine squared x over 2, is 1. By that, very important Pythagorean identity of trig, right? The Pythagorean identity of trig. And so what I'm saying is that we could write that 1 as sine squared x over 2, and then we got to keep this part, right? And then at the end, cosine squared x over 2. As I've already said, this guy and this guy combine to 1, and the rest is the rest, right? Okay, cool. Now, so, as we said, these guys, the three of them, these guys here, make the perfect square a plus b all squared. So that in this case is sine x over 2 plus cosine x over 2 all squared. And so this here, a plus b all squared, is sine of x plus 1. So the square root of sine of x plus 1 should be the square root of a plus b all squared, and therefore just a plus b, yeah? Okay, cool. So I'm saying that since that's that if we put square roots on that, we could put square roots on this. And so that means, as I said, that square root of sine x plus 1 is the same as this here, right? Okay, cool. Now, furthermore, notice that sine x over 2 plus cosine x over 2 is equal to 2 times cosine of x over 2 minus pi over 4. Now, you could pick up a pencil and a paper and see to it the cosine of alpha minus beta formula times root 2 gives you this exactly, but it does. And I'm not going to demonstrate that here because it's not really terribly interesting, right? So, but I will, in the argument, kind of get common denominators here so that I could make a u substitution where u is equal to this, because what we're saying is, since this is equal to this, and this in turn is equal to the square root of sine x plus 1, we're going to write in our integrand here, in place of what we have here, this guy, right? Okay, so that it'll look like this. As I said, we're going to make a u substitution, and the u is going to be this here. And this here is going to replace this guy in the integrand. But yeah, we have to also change the limits to be about u. And so it is 0 turned to. 0 is x, right? So that it'd be 2 times 0 minus pi over 4. So that's negative pi over 4. And for pi over 2, it'd be 2 times pi over 2, which would be pi minus pi over 4. And so 0 over 4. So we'd go from negative pi over 4 to 0. That's how the limits change. Otherwise, we're ready to rewrite the given integral now. As we said, that there, right, is the same as that there, which in turn is the same as this guy here, right? Okay, so we write the root 2 in front of the integral, and the rest of it is going to say cosine u. And so we have to figure out what du is, or rather what dx is in terms of du. So first, since u is this, du is going to be just a half dx, right? That's easy enough to see. So dx is 2 du, and so in place of dx here, we're going to write a 2 du, but that means we write the 2 outside along with the root 2 that's already there. And so 2 root 2 is in front of the integral, and then du inside, yeah? Okay, so the antiderivative of cos u is just sine u. So we have 2 root 2 sine u evaluated from, I had to get that vertical line right, evaluated from negative pi over 4 to 0, right? And so that would be 2 root 2 sine of 0 minus 2 root 2 sine of negative pi over 4, which amounts to, well, sine of 0, 0. So it's 0 minus 2 root 2 times sine of negative pi over 4 is, what's that? Sine of negative pi over 4 is negative 1 over root 2 because sine is negative in the fourth quadrant, right? So there that is. And of course, the negatives cancel, the root 2's cancel. So the final answer is duh. Not duh. Duh. Yeah? Okay, cool. Take care.